Thanks everyone for coming. And my name's Corey, and so today we're gonna have Will talk about Kotlin. And what happens is, if you're interested in doing a talk, you're welcome to just come and talk to me, and we'll put you down for a month. And then I just have there's a few things I try to do every meetup. I try to set it out at the beginning. We try to learn something. We want it to be very informative and learn something new. And we also want to have fun, and so it's not too it's not too straight-laced. I wanted to have something fun. And the third thing I try to do is I encourage everyone to introduce yourself and say hi to people and get to know people, which isn't always natural for people who program all day. Sometimes it can be a little reclusive, but I encourage you to go talk to someone, say hi to someone you don't know. And that's it. Well, thanks, and here's Will.
All right, thanks, Corey. So I'm Will. My background, I've been using Java for the last 5 or 6 years. The last couple of years, Kotlin's been sort of mixed in there. And I've been pretty excited about it. I found it a productive language, sort of very expressive in ways that people like functional languages for, but it's not sort of so scientific that it's hard to approach it. So it's kind of trying to strike that middle ground. So that's why I wanted to talk about it. So this is mostly going to be about sort of some of the language features, and not so much about sort of the Java ecosystem, because Kotlin is actually sort of a multi-paradigm language. I'll get into that a little bit more, but it's going to be focused mostly on sort of some of the unique features of Kotlin. And if people have questions after that, I'd be happy to answer them. So getting started. So if you go to kotlinlink.org, this is what it tells you, which I don't find to be super inspiring. So it's a statically typed programming language for modern applications. And it throws Java and Android on there, which probably don't really help with the adoption. So one that I like more is from a guy named Steve Yeg, who's sort of a programmer / blogger. He worked at Google and Amazon. He said, Kotlin is just plain fun. Maybe it's subliminal advertising, since the keyword for declaring a function is fun. But somehow it turned me from a surely professional programmer into a hobbyist again. So like that sort of stood out for me when I read it, and I kind of agree. Like it's just, there's something about sort of what it enables you in sort of an approachable way that sort of make it fun. So a little bit of background about it. This language is actually created by a company called JetBrains, who make IDEs. They've got a really popular Java IDE, Python IDE, JavaScript, C#. They've got lots of IDEs, so they're pretty good at it. So the fact that they're making a language, you might not be surprised. It's got pretty good IDE support. For a language like Java, which has like a really big ecosystem, that's pretty important. It's 100% interoperable with Java, so that's sort of like one of the initial sort of use cases, is use it for places where you would use Java. And it would run on the Java virtual machine. They've been working on it for about 8 years now. The 1.0 release was a couple years back, and the name Kotlin is an island near St. Petersburg, Russia. And that's actually where the initial development was done. And it's now actually a first-class language for Android. So Google now supports it with their sort of Android Studio IDE. So it's really gaining a lot of momentum recently. So some of the key characteristics about it. So it's a general purpose language, just like Java or C++ or any of those languages, it's statically typed. So you have the compiler, which helps you with certain things. It is multi-paradigm language, so unlike Java, which is pretty much strictly OO, you can just make a function if that's all you want to do. So that's a big advancement for the language. The compiler actually has multiple backends. So Java targeting the JVM is definitely the first one, but more and more it's getting features for JavaScript and sort of actual native binaries. And they're sort of developing an ecosystem around that with the idea that, write once and then deploy where you need it. So for instance, in the next coming release, they have a new random library, which can be targeted for any of these sort of backends. Typically, when you're first going from, say, Java, you would still be interoperating with a lot of Java libraries, which you can't bring into sort of the native world. So one thing that I thought was really interesting, when you look at their sort of goals for the language, they call out like 0 research papers. So while a lot of sort of new languages are kind of like academic sort of research projects, this is not one of those. This is focused on productivity, not sort of getting a paper written. And sort of related to that, it borrows pretty heavily from other languages, things like the concurrency model, and a lot of the syntax in general is just sort of borrowed from other languages that got things right. So that's sort of the general sort of area where it's trying to go and who it's for. So Java developers, that's sort of the first one, but it's moving to, that scope is definitely increasing. So that backend for JavaScript, so there's like a React wrappers if you just want to write like a React sort of application, you can use Kotlin for that now. Compiles to general purpose JavaScript. You can sort of interact with sort of your DOM elements and whatnot. So web developers can use it. The native backend sort of opens the door up for all sorts of different applications. So people are using it for like iOS applications with that. And there's sort of a new sort of shell scripting layer. So like you don't actually have to compile it. You can just sort of execute it with the sort of like a Kotlin sort of compiler / interpreter. But you just run your raw code and it will deal with compiling it and running it for just a script.
So you say how you can tell that you really like
Sort of. So it's definitely intended to be compiled, but there is sort of like a REPL environment if you just wanted to sort of dynamically play around with it. And sort of using it like a script, that kind of makes it look a little bit like a scripting language, but it's definitely not. Like, it's not going to run right away because it actually has to do, yeah.
So,
exactly.
so you still have to write a script, but you still have to compile and then run.
Sort of. I'll talk about that a little bit more, but you don't have to do that separate step. So. KT. KT. Yeah. And if it's a script, it's KTS. S. Kotlin script. Yep. Okay. So I took these images from kotlinlink.org. So they say why you want to use it. So the syntax is concise. It has safety features related to null objects, and which is really cool. I'm going to talk a lot about that. Interoperability, sort of those multiple backends I was talking about, and tool friendly. So they're an IDE company. They want to sell IDEs. So okay, so jumping right in. So most of this presentation from here on out is going to look like this. So I'm going to talk a lot about sort of the syntax and specifically what that helps you do. So here's your Hello World program. If you're familiar with Java, which I know most people here aren't, a main function in Java, that's your program entry point, and it accepts an array of strings. So not surprisingly, this function is named main. That's important, and it accepts an array of strings. So that sort of goes into the interoperability. And then it prints hello world. So compared to Java, that print line would be system.out.println. This sort of just removes that unnecessary boilerplate for something like a print statement, which you're going to do all the time. And just a little bit about the parameters. So the type is an array of strings, and the parameter is named args. So here we have values, and one thing that Kotlin gives you is it encourages you to use immutable values rather than variables. And you do that by using the val keyword. And there's a couple things here. If you look at this first name, you can see that it's actually defining the type as string. And the IDE actually marks that as gray and puts a squiggly line under there because it already knows that because there's a string on the right side. So the second one, you can see that's omitted. And sort of the IDE has lots of little things like that. If you're sort of working too hard, it'll tell you. And here's print line again. You can see, I don't talk a lot about this, but inside the quotes, there's a $sign. This is sort of string interpolation that a lot of languages do. It just makes it really easy to, output your data. So in this case, it's inserting those two values into the string. Yep. So you could just put anything that isn't preceded by a $sign, that will just be a string. So in this case, there's just a space character. And we'll show more of these later. You can put semicolons, and it will gray them out and say you don't need to have that. So that's the immutability piece. So if I wanted to change my first name, well, that's a value, so I can't change it. So, so I'm glad you asked that. So these are immutable values, and there's a lot of tools in Kotlin to sort of make it easy to use immutability. Okay. Correct. Now, on the other hand, if you wanted to change your name, you'd have to use a variable. So, val and var. So,
it's almost like constant.
Exactly. So now we can talk about a little bit about nulls. So, a value, in this case, you can see x is an integer, and an integer is not a null value, so you can't assign it null. Y, on the other hand, is a nullable integer, so there's a question mark there. That might be null, so you can set it to null. And also, since x cannot be null, I can deprecate it. I don't have to check if it's null first. It's an object. On the other hand, y might be null, so I can't run a function on it. So the compiler says you can't do that because that's not safe.
Is that a space after the x?
Yeah, there doesn't need to be a space there. Yeah, so this is a really important feature of Kotlin, and I think probably one of the more unique features. It's probably more important for people who come from a Java background, who are used to null pointer exceptions just happening when you don't want them to. So a little more about that. So here we can see again, so there's a string which is not nullable, so that's an error. And here again, you see we can call a function on string. But what about the nullable string? Here again, you see it might be null, so you can't just call a function on it. So how do you work with null? There's a couple different ways. So Kotlin has a feature called smart casting. If you check something, so this works for checking for null, or maybe you want to check if it's a certain type. After you do that check, you can just sort of use it in your code as though it were that type. So in this case, we check if null string 2 is null. If it's not null, then we can call our function. And there's also the so-called Elvis operator, the question mark with a dot after it. That's sort of the same thing. So actually, if you notice underneath the if, there are squiggly lines. So the compiler will tell you you can use the safe operation question mark dot. So that's to show that you can chain these operations. So in this case, I want to reverse the string and then mark it uppercase. Yeah, so the reason for that is because if it is null, it's going to return null. So in the second operation, so if I understood correctly, you're talking about the return value of reversed. So if it is null, it'll return null. I'm not sure I follow. I'm not sure I followed. I think so. You're asking why I need both of these? Yep. Yeah. So basically, what would happen is this portion here would evaluate to null, or it would evaluate to a reversed string. And once that evaluates, now we can call something else on it. But if it had evaluated to null, now we have null and something executing against it. Yes. Yeah. Yeah. I'll probably try that later just to double check. Yeah. But I suspect that if it worked that way, the compiler would have said that you don't need to use the safe operation.
Is it like block scope or like anything between the block and the compiler is already created, so you don't have to do the if check anymore, or is it like how does the compiler do that? You know what I mean?
Yeah, so I think that I think that if you had done this, then so it would have had to have been inside the block. So if you opened up a block after that null check, then anything inside that block. But it's generally pretty smart about it, including If you have volatile variables that might be changed by another thread, then it doesn't always work. So it generally seems to be pretty good. Okay. So a little more on this. So here again, you see sort of the return value that counts for results of functions as well. So you can't return the result of that reverse string to something that's not nullable. And then you have default operators. So this is always useful if you don't want to have nulls in your program. If you pull in a library and it's returning a nullable value, maybe you want to assign it to a default value. And you do that with just a question mark colon. That's sort of like the else case. So if it's null, or if it's not null, use it, else you have a default value. Or maybe you just want to throw an exception. So these are sort of the different tools that you have for working with null. And sort of throughout the language, these are used. So assuming you write your code to use that, it sort of adds a whole sort of layer of safety that you don't get with a lot of languages. And here's one last example. So this is true for parameters as well. So here the parameter of this function, one of them is nullable, so you have to be careful with that particular one. And also here is the standard sort of string library. So a lot of the libraries are very rich. So like here's one that lets you sort of pad the left side of the string. Some languages don't have this. Oh, sorry. Yeah. So so like for example, calling reversed on param1, it would say this isn't a safe call you need, and it would tell you how you could go about solving that. And also the return type here is an integer. It's not a nullable integer, so you can't return null from this function. Okay. So function syntax. Let me see if I can turn off the lights.
Yeah, I can see. It's even better.
Okay. Okay. So yeah, so this probably looks pretty familiar. So it's a function named maximum. It has two parameters, and it returns an integer. So one thing I really liked about Kotlin is that if you just want to write code this way, this is pretty much how you write code in any language. So, if you're used to sort of a C-style language, you can start here. And in some cases, the compiler will sort of like tell you things that you can do. So for instance, if has a little squiggly line under it, and it tells you, or actually, yeah, so there's a compiler hint there. So it's going to tell you that if can be an expression. And if you tell the compiler, okay, show me what that looks like, it will change it into this bottom version, which says return if else. So now you only have a single return. And if you want to take that even further, so there's actually only a single expression in this function, so you don't need that block. So here at the end of the function, there's an equal sign, so there's actually no block associated with this. There's just a single expression, and we don't need to return it. So that function is that expression. And then you can write that in one line if you want. And it also has type inference. So in this last version, We don't say that it returns an integer. We don't need to because we see it returns first or second, so we know it's an integer. So these are all the same code. It's going to compile to the same thing. Okay, so how do you call that? So here's our main function again. You call it just like you call any other function, or if you want to, you can use named parameters. This is really useful if you have a big function that has a whole bunch of parameters. In a lot of languages, you would maybe want to create some sort of like builder pattern to build up these parameters. Kotlin just sort of lets you name the parameters, which is really convenient. So you can just sort of write it like this. It also has default values. I'll get into that a little bit later on.
Does the naming of the parameters, does that just help because it doesn't have to be in order? Like if you have 3 parameters.
Sure, so if you use named parameters, you can put them in sort of whatever order you like. Okay. So because you need data structures to do a lot of work, there's a very rich set of data structures, and I'm sort of going to go over a few of them. So for instance, here we have list. If you want to sort of define a list, it's very sort of succinct. You say, I want a list of, and you put some values in it. In this top example, you actually don't have to say that it's a list of integers. That can be inferred, or you can put it there if you want to. Depending on what you're doing, you might want to leave it there. And then here's sort of a few things you can do. So any collection, you can sort of apply functions to it. So in this case, you can apply a filter, say I only want numbers that are greater than or equal to 3. Okay, yeah, so these curly braces here, so that's actually a lambda. So this is sort of a function that gets passed into the filter operator. So what this is sort of a streaming process. So it says, given a list, pass each value into this function, and the value is called it. You can name it, and I think in other examples I named it, but I forgot to cover that first. So in this case, it is just one of the values in that list. So if it's greater than or equal to 3, then we'll keep it. Then we pass it into filter not. So in this case, if it's even, you don't want to keep it. And finally, there's sort of a for each. So pass each value into this last one, and it prints. So Corey, here you can see there's just a string, and we just sort of use string interpolation to put the value at the end there. So this whole thing would print out odd numbers greater than or equal to 3 are 3 and 5.
So do you see a lot of Kotlin code functional like this?
Yeah, so these sort of patterns are also becoming really popular in Java. So it may not be a coincidence that sort of they're doing it in this format, but yeah, this sort of programming is very common in Kotlin.
But that list is inherently immutable.
So I'm going to get more into that next, because the next one is a mutable list. So list is actually an immutable list. So by default, most things in Kotlin are going to be immutable. So you can call it a mutable list, in which case you can now sort of add and remove values from it. So here's a mutable list of integers, and I'm using sort of a range feature. I don't go a lot into that in this presentation, but here you see 10 down to 1. It's going to start at 10, 9, 8, 7, 6. and go down to 1. And it adds those to the list. And then this is just showing that the thing is being mutated. So 5 times I'm going to run this function inside here. And you can see in this case, right after the for each, there's index. So in this case, I named it something else. So I named it index. And because it's mutable, it has a shuffle function, so it's just going to shuffle it. And then I print it. So finding the first even value is basically what's happening here. And in this case, I decided not to use string interpolation. So you can still sort of like append strings together if you want to. Yeah, so the reason why it's still a val is because it's only going to be that list. Although the list is changing, it's not going to be assigned a different list. So this has to do a little bit with how Java works. The value is a reference to that list. So although the list itself is changing, it's still pointing to the same list. So if I wanted to sort of reinitialize it, I couldn't say mutable list equals mutable list of. I'd have to say like mutable list dot clear to remove all the values from it. Okay. So there are maps. So the syntax for using maps is kind of convenient compared to Java as well. So same way you create a list or a mutable list, you say map of, and this time you provide 2 values. So in this case, it's an integer to string map. So here's 0 to 0 and 1 to 1. Yeah, so it's a hash map. And you can sort of see string interpolation here again. So if you want to get the value, you can use sort of square brackets. And in this case, in the second print line here, you can see you can ask for a value that's not in there, and it's going to return null. And if you wanted to sort of make your code null safe, there's 2 examples. So sort of the Java style would be map.get or default. So get the value at index 2, or get the string boo. Or you can use sort of that Elvis operator again to provide the default value. Yes. Yes. So the Elvis operator is the question mark colon here.
Oh,
Because sort of if you turn it sideways, it's got like the hair.
that's what equals.
Yeah, so it's kind of like an else. So it's like for dealing with nulls a little bit. And that's not my term. That's what people actually call it. Okay, so there are arrays. They work pretty much the same as a list. And there are sets. So yeah, correct. So so you do get out of bounds errors if you try to go out of bounds on an array. And yes, so this is just showing if you add the same value to the set twice. It says the size is 2, even though I tried adding 3 things there. Okay. Yeah, so sets are sort of a special case of a hash map. So it's a hash map without sort of the value associated with the key. So when it goes to add 1, when it inserts it, and then when it goes to add it a second time, it's like, well, it's already here. So yeah, so in some cases, it's just a good way to sort of deduplicate, sort of like a streaming way.
surprised that the content is not flashy, but
Yeah. Okay. So, so default arguments. So here's sort of a, so one of the built-in utilities is sort of a join to string function. So say you have one of those data structures and you just want to turn it into a string. So we have this join to string function. And you can see I'm using it in two different ways here. And it actually has 6 sort of parameters, but I'm not providing 6 parameters in either of these calls because they all have default values. So if I call data.joinToString, I can sort of say, like, okay, I want it to say none and be wrapped in parentheses. So here you see that's what's being done at the bottom here. And although I specified here the first parameter corresponds to the separator, that actually I wouldn't have to specify that if I didn't want to, because that's actually what the default value is. And here I decided to specify these 3. So in the second one, so I changed the, it looks like I forgot to recompile the code for this last example. So the separator, when I created that example, was a space. And then I gave it a limit. So actually, although there are 4 items in the list, it only printed the first 2. And then it says truncated. That just, if it truncates, it adds this to the end of the string. So this is sort of an example of what you can do with default values. It just sort of, you write what you need to, and sort of the compiler can infer a lot based on what it knows about the function. And don't worry too much. In the function, there's sort of T in angle brackets. That has to do with sort of generics, which is a more advanced topic that I'm going to get into. So default arguments are great when you have a problem that needs them. Okay. So a little bit about classes. I really don't talk a lot about classes in this presentation, but Java is a completely OO language, and you can do whatever object-oriented stuff you want in Kotlin as well. And the syntax is very sort of terse, so you can express a lot compared to how you would in Java. So for instance, in this class, so there are 2 member variables, and they're actually specified in the class definition right at the top. So it has a string called text and a private variable called count. So in this main function down here, you can see, so initializing a value of my class with values test and 5, and I'm printing. So I can use sort of a dot to get that property. So this is printing text. The text is test. And then if I wanted to call count, it wouldn't let me because that's a private property. So that's commented out. And then there's one function called repeat. So this is just sort of using another one of those sort of list operations. So this is now a fold operation, so it's sort of building up the string and appending the text a bunch of times. So if you want to use an object-oriented approach, that's totally fine. Okay, so from here on out, it's mostly going to be code examples, so different ways you can use the language. So here's an example of sort of working with null that is sort of more involved than the ones that I went over before. So at the top we have a function called might be null, and it's taking a random number and checking if it's even. And if it is, we return the input. Otherwise, we return null. So yeah, so the argument, so might be null is accepting a string, and randomly it's either returning the string back or returning null. So this is just like, okay, so suppose this is like an HTTP request. Maybe you get a good result, maybe you don't. So here's a function that you don't know if it's going to give you something good or not. So down here, there's another function called dealing with null. So this is using that range operation again to call our function a bunch of times. And here we see the safe sort of access method. So we want to take our string and make it uppercase, or we want to have a default value. So here we see the else operator again. And that's going to tell us that it was null actually. And here's our main function. We're going to pass the Leominster code meetup, and here's our output. And you see sort of, sometimes it was null, and sometimes we get back our input, but it's all capitalized. So this is sort of pretty typical for how people might write Kotlin code. Okay.
So the 0 is
Yeah, so this one, I think it actually does it 11 times because I think it's inclusive.
okay.
But yeah, so it's sort of the range operator, and there's a bunch of them. So you can say, if I don't want the inclusive version, you can say 0 and then use a keyword until 10. And there's also ones that go like down to or down until. Yeah, exactly.
So this is like all the functional documents, you know, all of that. It's a functional document.
Yeah, so sort of. Yeah, it's definitely sort of lightweight functional programming. Which is more my speed when it comes to functional programming. So it sort of like lets you use these sort of techniques in a friendly way, I like to think. Especially like for each, like that sort of is easier for me to translate. Like, okay, so I can do a for loop, or I can just apply this function to each value inside this collection. Okay. Okay, and here's just sort of another example. So, and this actually shows a couple interesting things. So at the top, you have the main function. And actually inside this function, I'm declaring another function. So these are just sort of, it's very fluid for how you want to do this stuff. So in this case, I have a function called illegal number, which says, the number 3 is apparently illegal, so that's just going to tell you about that. And we have something called a data class, which has to do with Java mostly, but this is actually a fully defined class called num_tuple. It has 2 parameters, so you can sort of create things with them. And that's an object, so you don't need to have more than that if you're just storing data. And if you look at the second value, the name has a default value of null, so when I create it, here I'm creating 2 of them, and in one of them I'm only providing one of those arguments because the second value has a default. And now just for fun, I'm creating a list of lists, and it has sort of 4 of these num_tuples with the values 1 through 4, but they're sort of like shuffled up and they're in nested lists. So like, what if I wanted to print those out? So here's just sort of those functional style screens. So like a flat map will take your list of lists and sort of flatten it out for you. So it's just like 4 values, one after another. You can sort and provide a parameter. So In this case, I'm saying, okay, I want to sort by the number, and I want to make sure none of them are illegal values, so I pass in this illegal number function, and then print them all. And it prints 1 written out, the number 2, and then 4. And the reason why it does that is because the name is defined as knowable, and in this case, it doesn't have the word for it. So it uses the default parameter.
The functions accept functions as
They do. If I go back to this. So this function join to string, the last parameter is a function. And the function is given one of the values. So t is kind of like a wildcard. So given one of those, give me some characters. And Kotlin actually has some syntactic sugar for that. So whenever you see these curly braces at the end of a function, that's getting passed into this argument. So this join to string sort of function here, it accepts a function, which is sort of how you want to actually format it. So that's kind of like a very common pattern. As you can see, like all of these sort of streaming functions that we've talked about, they all use this pattern. So these are all functions being passed into these sort of streaming operations. Okay. So that covers most of sort of syntax stuff. So I'm going to go now into a couple of small projects to sort of show like how it might come together, like if you're actually using it for something. Very small projects though. Okay. Are there any questions before I move on? All right. Okay. So I know there's a lot of sort of web developers at this group, so I actually dug into the JavaScript features a little bit. This is the first time I've done that. So here we have 2 files and what it renders to when you run it. So on the top, this is hypertext markup language. And it's got an element called an input element. And besides that, it just imports a couple scripts. So those scripts are the artifact from compiling your Kotlin code. It's really long, so I sort of truncated a little bit. But there's sort of a library function called kotlin.js. And then your code compiles just to a single JavaScript file. And my code here, there's a main function. And all it's doing is it's using sort of this library called document, or I guess it's importing an object. And it says, okay, give me the body. And notice there's a dot, so I guess there's always a body in your HTML code. But there's not always a style. So in this case, we're using sort of those safe operators. So this is setting the background to powder blue. And it's also looking for an element in email, is what I named this one. And it's casting it to an actual object. So within sort of the Kotlin language, there is a class HTML element that'll let you do things like set the value property. Yes, exactly. And actually, yeah, so as is a cast. So in a lot of languages, that'll be like inside parentheses. So that's what's happening here. So that actually, yeah, that was all there was. So I created this, and then I dropped that HTML file inside the project and directed it to the artifacts, and it opened right up.
So you wrote this part, that includes that part, and then you put that
Yeah. So
connect to that.
yeah. So in the IDE, so here, the out directory here, that's sort of where the artifacts were put by the IDE. So I didn't actually really configure a project. I just said like new JavaScript project, and I put that in a file. And I can bring that project up a little later if you guys are interested. But I have no idea. But that's probably a great question. Okay. Okay, so I created a small sort of web server using a library called Javelin. And this is sort of showing how you use it. So the actual code that I'm going to show you in a minute is less than 35 lines, but here you see I launched it, so there's some default values. So give me user number 2, it says Corey, and his sign is Virgo. And here's a put. That's it. So put ID 3, someone named Ben who's in Aquarius. So user created successfully and prints it out. And here it's now getting that user. And you see everything again. So this is just some library. So there's actually a lot of sort of micro web framework libraries, and this is one of 5 that I got when I searched for micro frameworks for Kotlin. And this is the entirety of the code that does that. At the top, so here's a mutable map. So I create some data. You can sort of imagine that might be connected to a database. This line right here is actually creating a server, starting it on a specific port. And then we're hooking up a few routes. So here you see user, and it has sort of an ID. And there's some utilities here, so give me the path parameter, convert it to an integer. And sort of that int value is now named CTX for context. This is sort of a pattern for this library, so I sort of followed what the recommendation was. And here we see, so give me that ID. This is sort of a helper that is useful for like, if you want to work on a value but you don't want to assign it somewhere. So here we have question mark dot, so it might be null, so we have to handle null. And so let is sort of a function that just sort of passes it into the function so that you can use it without assigning it somewhere. So if we have a value, we set it to the context, and that's going to get returned. Otherwise, here we have the else operator again. Otherwise, we set an error. So this wasn't found. And same with create here. So now we actually have, so one thing to keep in mind, so at the top here, we're actually creating a user object. So this is actually sort of doing the serialization to and from objects for us automatically. So here we're creating a user, and it adds sort of a helper to, like, okay, attached to like the payload of this request is a serialized version of this user. So say validate it. Actually, we want to have error handling. If we're trying to create a user and we're passing the same index, say you already have that ID. And it's actually going to throw an exception to terminate the handling at that point. So if we get here, we can just go ahead and update our data structure. And then we return to a because we have created that user. So this is the message that we saw. User created successfully. And it prints out the user. So this is just sort of, I think that quote at the beginning where the guy says, using this language is just kind of fun. Like I find, like I could just sort of, what I'm thinking about, I put it up there. I don't have to worry too much about the extra stuff. So like every line of code here is doing like a lot of things, but sort of I find it has a nice level of expressiveness, so it's not like too much. It's like a nice balance compared to languages like Scala, which are doing too much for me sometimes. Okay. Okay, so we're getting towards the end of my presentation. There's a lot of things I didn't cover. So I sort of covered the high-level things, like the mutability stuff is really important, the collections are really important, the nullability handling is really important. But there's a lot of advanced things that when you're writing big applications become more and more important. So like generics. There's a lot of improvements over Java, which already has pretty good generics. So this is like creating your reusable data structures. There's a feature called coroutines. That's sort of their version of concurrency. It's sort of inspired by a lot of different languages. So like Golang has channels, I think. It's sort of inspired by that, the sort of async and await that Python and JavaScript do, inspired by that. So it's sort of, it's not breaking new ground, but it's trying to sort of take the best of what's available. We talked a little bit about the IDE support. The debugger is pretty fantastic. There's actually a Chrome extension that lets you debug the Kotlin code from like the Chrome browser. So like in the debugger, it shows you the Kotlin code, even though it's executing the JavaScript. So that was pretty cool. I'm not sure how they pulled that off, but it worked when I tried it. Exceptions, that's sort of a core Java feature. It's a core feature in a lot of languages. So I didn't talk a lot about those. Kotlin has a feature that I really haven't used very much, but it's called a type-safe builder. So it allows you to create very expressive sort of code to initialize things. So you can write basically HTML that looks like HTML, but with those like curly braces, and it's going to be type-safe. So the ecosystem for Java is extremely rich. So there's a lot of tools just in that ecosystem. I didn't cover any of those. So there's a lot that wasn't covered here. Yeah, and the Java side of things, that's where most presentations start for talking about Kotlin. But I tried to skip most of that since it's, I think the language is interesting enough, even without saying that it's a better version of Java. Okay. So maybe you want to learn more. So there's lots of good resources. There's lots of books at this point. There's actually a try.kotlinlink.org. There's a really good web app for just sort of trying it out. There's some starter code for just sort of getting started. I thought I had a KScript example, but that's probably a good way to get started too. It's like you don't have to worry about sort of compiling and setting up a project, just putting some code in there. The documentation is actually really good, and it has sort of executable blocks of code in line with the document. And if you happen to be a Java developer, right-click on your file in IntelliJ, and there's an option that says Convert to Kotlin code. So it's really easy to get started. You can just convert some of your code into Kotlin, and it's completely interoperable with the rest of your application. I don't think so, actually. So maybe save before you do that. Yeah, so there are a ton of high quality sort of Android libraries. In fact, most of the libraries for Kotlin are going to be sort of Android centric. So I'm using Kotlin sort of as a sort of backend for a software as a service application. So I generally don't benefit from that, but that's definitely sort of the main sort of initial group of users. And the reason is actually kind of interesting. So the version of Java on Android devices is typically pretty old. And old versions of Java were not good. Like there's a lot of missing features that they just can't use. And Kotlin can compile it into that old bytecode. So they can get sort of those new language features without a newer version of the runtime environment.
So can you, so like, Android, can you, write Kotlin and then call some Java library or something?
Sure, yeah. So Android is already Java, so Kotlin interoperates with all that really nicely. Okay. So there's just a few more slides. So here's the web app. It kind of looks like what you'd expect from a prior language on a web page. It's got, at the top you can see this sort of like, it says chapter 2. There's a ton of like code examples here. So if you just want to see what it looks like, you can. Here's the documentation. It's pretty good. I like it. Let's see. This is supposed to be a little animated GIF, but it is not. Oh, there we go. So I just wanted to show this is in line with the documentation, and it's sort of executing the code, and you can edit that if you want. So here are those range operators used in the context of a for loop in this case. So I was actually pretty impressed by this. And okay, so here's the K-script example. So here you can see, so it's just a function, and you execute it with this command, Kotlin C-script, and you just execute it. So there's no compile phase here. So this is actually pulling in a Java dependency and just sort of running it for you. There's lots of libraries. Nice links. So that is everything I have prepared.
So currently calling, normally using Android, right? Who are using it?
Sure. So I use it at my work, and we use it just for a Java application. So if you're a Java developer, you can use this whatever your application. It's a pretty big project. So who uses it? So anyone writing Java code can use it. But it also has, so that was definitely the primary use case for this language. But now that it's growing, it's gaining sort of some traction. So they're working more and more on the JavaScript features. So like while I was investigating this, I found they actually maintain a sort of React project wrapper. So it just wraps React and builds a project so you can make your app with Kotlin. So that's something that they're actively working on. It also has sort of a native backend, so you can generate native code. I think it's still garbage collected, so it might not be like as native as some people want it, but it's still sort of moving in that direction. So that if you want to use it in like an iPhone application or on some server that doesn't have Java installed, it's a possible solution. But those are definitely sort of not as robust right now as the Java portions. So I don't have this online yet, but I'll put it online, and maybe we can put it in a link on the Meetup if anybody wants to check out these links or follow up with me. So that's where I pulled the quote from. So that Steve Yig guy is a blogger, and he created a blog post called "Why Kotlin is Better Than Whatever Dumb Language You're Using Today." Yeah, yeah. I think his webpage is actually called Steve's Rants.
So when you say Kotlin is strong types of every